Hello, welcome to the video notes for lesson 7-6. This is the second part of linear functions, and this begins on page 31 in your notes packet. So you'll see the same thing in your notes that you see on the screen. And our target for this lesson is I can determine if a function is linear by determining if it has a rate of change. Okay, so our first example, the function m of w equals 1 over 6w, which describes your weight on the moon as a function of your weight on Earth, w, in pounds. Alright, so we know that this is a function because, well, if we look at the table, every input value has exactly one output value. Also, remember that the input is the x values and the output is the y values. Now, when we look at the table more closely, the input values are increasing by 30 every time. Plus 30, plus 30, plus 30. All right? And then when we look at the output values, those are increasing by 5 every time. Now in the last video, the first one about linear functions, you learned about the change in y, delta y, change in y, over the change in x. So when I look at the change in y, that's increasing by 5, or positive 5, over the change in x, which is 30. Now, 5 over 30 simplifies to 1/6. So what does that basically mean? First of all, this is our constant rate of change, our slope. And what that's telling us is 1 pound on the moon for each 6 pounds on Earth. So the number on top is the weight on the moon, and the number on the bottom is the weight on the Earth. So for every 1 pound on the moon, on the moon for each, or for every 6 pounds on Earth. So if you have something that is 2 pounds on the moon, it would actually be 12 pounds on the Earth. If you have something that's 10 pounds on the moon, well, 10 times 6, that's 60 pounds on Earth. Okay? So that is our constant rate of change. So this is a function because every input has exactly one output. It's a linear function because there is a constant rate of change. This is that constant rate of change. All right, so now let's take a look at the next example below. Suppose you drop a stick from a cliff 30 feet high. The force of gravity causes the stick to fall towards the Earth. The function h equals 16t squared plus 30 gives the height of the stick h in feet after t seconds. Alright, so now let's look at our table. They label it t and h, but really that's like x and y. Now look at our amount of change. So this is increasing by 0.5 every time. And then when I look at this change, the change in y, so from 30 to 26 is minus 4. From 26 to 14 is minus 12. From 14 to negative 6 is going down 20. And from negative 6 to negative 34 is going down negative 20h. Okay, so is this a linear function? No. Actually, is this a function? Yes, it is a function, but it is not a linear function. Not linear. Obviously, if you look at the graph, you notice that it's not a straight line. But the reason that we're going to give isn't because it's not a straight line. It's because there is no constant rate of change. Alright, now let's take a look at an example on page 32. We'll have a couple of questions that we'll answer. Hopefully this will help you understand this even more. And then we'll be done. Whoops, let me get back there. Okay, so this is a wonderful example to go through and help us understand what this constant rate of change thing is and what we can use it for. When a scuba diver goes underwater, the weight of the water puts pressure on the diver. The table shows the water pressure on the diver increases as the diver's depth increases. In other words, when they go deeper and deeper underwater. So the diver's depth is increasing by 10 every time. And then when we look at the water pressure, the amount of pressure in pounds per square inch is increasing by 4.4 every time. So, is the relationship between the water pressure and the diver's depth a function? So look at the input values and look at the output values. Is there one output for every input? Yes. So, yes, each input has exactly one output. Okay. Is the relationship between the water pressure and the diver's depth a linear function? If so, what is the rate of change? The answer is yes, because there is a constant rate of change. Okay, so now we have to say what the constant rate of change is. And the way we do that is by putting the change in y over the change in x. And that is 4.4 over 10. Now this is not a good way to leave the answer. We should actually convert it to the number that it's going to be, especially if it's not a bad decimal, and this one is not. This will equal 0.44. Now we need a label. The label for this one is actually not a very nice label. Usually it would be something like feet per second or something like that. This one is actually, so the 4.4 that's on top is pounds per square inch over per feet, per 1 foot. Okay, so it's changing the water pressure, the pounds per square inch, is changing 0.44 for every 1 foot. So what does this rate of change represent in this situation? For each foot, for every or each foot of depth the water pressure increases, the water pressure increases 0.44 pounds per square inch. Okay, so there's one more question, and actually I'm going to let you answer this on your own. Use the rate of change to predict the water pressure on a diver at depth of 60 feet and a depth of 100 feet. There's two answers there. So if I can get two questions there, 60 feet of depth and 100 feet. If I can get two different people to give me the correct answer, and then two more people to explain how you could get it, that's a total of 4, then I'll give you up to 4 points on your scoreboard for answering this last question. Use the rate of change to predict water pressure on a diver at a depth of 60 feet and a depth of 100 feet. Alright, if you have any questions, make sure you come and see your math teacher or get help from somebody at home or a friend. Good luck, and we'll see you in math.